In physics, you're often going to construct equations and then try to solve those equations for the unknowns. In this tutorial, I'm going to remind you about some of the basics of solving equations for unknowns. We'll begin with the case where you have a single equation and a single unknown. And we'll focus on the so-called linear case. So here's an example. 3x plus 5 equals 2x minus 4. This is a single equation. We have one unknown, x, that we're going to attempt to solve for. And it's called the linear equation because notice that it just involves an x term here. There's no x squared or x cubed terms appearing. Now, when you're solving this or any equation, the basic idea is think about this as a balance. We're saying this side balances that side. So if you like, think of a scale. So that means that anything I do to this side, if I do the same thing to that side, they'll remain balanced, in other words, equal. So for example, I could add 32 to this side, provided I add 32 to that side, and the two sides will remain balanced. I could subtract 11 from both sides of the equation. I could take the square root of both sides of the equation. As long as whatever I do to the left-hand side of the equation, I do the same thing to the right-hand side, they remain balanced. So that simple principle will allow us to solve for the unknowns. So let's begin. Notice that there's an x that appears on the left-hand side as well as on the right-hand side. So what I want to do is try to collect those x's so they all appear on the same side of the equation. So I can do that as follows. I'm going to subtract 2x from both sides of the equation. Remember, I'm allowed to do that because as long as I do the same thing to both sides of the equation will remain true. So when I subtract 2x from both sides of the equation, on the left-hand side, I just get 3x minus 2x is 1x. So that's x plus 5 is going to equal, now on the right-hand side, I have 2x minus 2x. That gives me 0 minus 4, so negative 4. Now, I'm allowed to do the same thing to both sides of the equation, so I'm going to subtract 5 from both sides of the equation. And when I do that, on the left-hand side, the 5 and the negative 5 will cancel, so I'll be just left with x. And on the right-hand side, I'll get negative 4 minus 5 is negative 9. So there I have my solution. Let's look at another example. Suppose I want to solve the following equation. ax plus q equals bx plus w. And in this equation, I want to think of x as my unknown. That's what I'm going to try to solve for. And a and q and b and w, think of them as known quantities. They're given. You can think of them as being ordinary numbers, although I haven't written them in numerical form. But just think of those as they're given to you. A might be 11, Q might be 13, who knows? But just assume that they're known quantities. Our unknown in this equation is x. So we want to solve for x. So again, we're going to try to manipulate this equation by doing the same thing to both sides, and we'll try to collect all the x terms together. So here we go. The first step is, notice I can subtract bx from both sides of the equation. And that's going to be useful because that's going to cancel out the bx term on the right-hand side. So when I do that, the equation on the left-hand side becomes ax minus bx plus q. And on the right-hand side, I have bx minus bx, that's 0, plus w. So now this is my new equation. Okay. Now, let me just manipulate this a little bit more. Notice that I have the ax minus bx term. I can write that as a minus b times x plus q equals w. Okay. And now, I'm going to subtract q from both sides of the equation. Again, my goal here is to isolate the unknown x. And when I do this, when I subtract q from both sides, the left-hand side becomes a minus b times x, and the right-hand side is going to become w minus q. Now my goal here is to solve for x, so I'm going to divide both sides of the equation by the quantity a minus b. And when I do that, the left-hand side of the equation, I have an a minus b over a minus b, which gives me 1 times x. So I'm left with x on the left-hand side, and that's going to equal w minus q over a minus b. There we have it. I should point out that often in physics, you're going to have equations, and there's going to be one unknown, in this example x, and a lot of other quantities that are written symbolically, but you can just think of those as knowns or givens, or if you like, numbers, but you're not actually told what the number is. In the preceding examples, we considered a linear equation with one unknown. In other words, equations like this, or like this, or even like this. These are considered linear equations because each side of the equation just involve simple polynomials that went up to x. There was no x squared term, x cubed term. This is just a simple polynomial, 2x minus 1. Here's a simple polynomial, 6x plus 3. A simple polynomial, 2x minus 7, or ax minus b. The highest power of x was just 1, and it was just some constant times x. Some constant times x. So just a simple polynomial here. On the other hand, sometimes you might encounter an equation that looks like this. This doesn't appear to be a linear equation because if I look on the left-hand side, for example, this is not a simple polynomial. It's, in fact, some type of fraction, like 6x minus 1 over 2x plus 3. So this is not a linear function right here. On the other hand, this really is a linear equation. It's just slightly disguised. The way to see that is as follows. Let's multiply both sides of this equation by 2x plus 3. That will enable us to clear out the denominator. And if we do that, we see now that this equation becomes 6x minus 1 is equal to, on the right-hand side, we have 8x plus 12. And this, we see, is a simple linear equation. Both the left-hand side and the right-hand side are simple polynomials, linear in x, 6x minus 1, 8x plus 12. So we turned what appeared to be not a linear equation, but in fact, it really was a linear equation in disguise. Next, we'll turn to the case where we have one equation, one unknown, but this is a quadratic equation. So here's an example. I want you to think of x as our unknown. A, B, and C are just known or given quantities. So we're going to try to solve this equation for the unknown variable x. It's called a quadratic equation because we see that we have this x squared term here. That makes it quadratic as opposed to linear. So how do we go about solving this equation? Well, the first thing we have to do is pull out the quadratic formula, which tells us the solution. And the quadratic formula tells us that the solution to this equation is x is going to equal negative b plus or minus the square root of b squared minus 4ac over 2a. In general, when you have a quadratic equation, there are two solutions depending on whether you choose the plus sign or the minus sign. In some cases, you'll want to know what both of those solutions are. In other cases, it may only turn out that only one of them is physically relevant. But that's going to depend on the problem at hand. So let's look at an example. Suppose we want to solve the equation 2x squared plus 6x minus 20 equals 0 for the unknown x. In this case, we see that the coefficient a is 2, the coefficient b is 6, and the coefficient c is negative 20. So we simply have to plug into the quadratic formula, and we find that x is equal to negative b, so that would give us negative 6, plus or minus the square root of b squared, so that's 6 squared, minus 4 times a, which is 2, times c, which is negative 20. This whole thing over 2 times a, which is 2. We can simplify this by writing this as negative 6 plus or minus the square root of 196 divided by 4, which is equal to negative 6 plus or minus square root of 196 is 14 over 4. And we see that if we choose the plus sign, then we get negative 6 plus 14, which is 8 divided by 4 is 2. Whereas if we choose the minus sign, we get negative 6 minus 14, which is negative 20, divided by 4, which is negative 5. So those are the two solutions. And it's always a good idea to verify your solutions. Plug in x equals 2 into that equation and make sure that it's satisfied. Likewise, plug in x equals negative 5 into that equation and make sure it's satisfied. Sometimes we'll encounter situations where we have more than one equation and more than one unknown. For example, consider the following. 2x minus 4y equals negative 20. So we have two unknowns there, x and y, and we also have two equations. We have this first equation and this second equation. As a general rule of thumb, if you have two equations and two unknowns, you can typically solve those equations for the unknowns. If you have three equations and three unknowns, you can typically solve those three equations for the three unknowns. If you have four equations and four unknowns, you can typically solve them. So let me illustrate how to do this in practice. The basic idea is that you take one of the equations, solve it for one of the unknowns in terms of the other, and then substitute that into the remaining equations. So for example, let me start with this equation here. I'm going to solve it for one of the unknowns. In this case, I'm going to solve it for x in terms of y. I could have, if I felt like it, solved it for y in terms of x. It won't matter. But I'm going to choose to solve this for x in terms of y. So here's what I do. I'm going to try to isolate the x's and get all the x's on one side of the equation. So here we go. I'm going to add 4y to both sides of the equation. Then when I do that, we see that the left-hand side of this equation becomes 2x. The negative 4y and the positive 4y cancel. And that's going to equal, on the right-hand side, I'll get negative 20 plus 4y. Then what I'm going to do is divide both sides of the equation by 2. Remember, you're allowed to do the same thing to both sides of the equation. It will still balance. So when I do that, 2x over 2 just becomes x, and on the right-hand side, I'll get negative 10 plus 2y. So all I did here was solve for one of the unknowns, x, in terms of the other. Then what I'm going to do is take this expression for x that I just found and substitute it into the remaining equation. So in other words, I'm going to now substitute that in. So where I have 3x here, I'm going to replace x by this. So that will become 3 times negative 10 plus 2y. And then I have plus 2y equals 18. So I just made that substitution. Now let me expand out the left-hand side here. I'll get negative 30 plus 6y plus 2y equals 18. Let me simplify it a little bit. Negative 30 plus 8y equals 18. Now I'm going to add 30 to both sides of the equation. And when I do that, the left-hand side just becomes 8y, and the right-hand side becomes 18 plus 30, 48. And now I'm going to divide both sides of the equation by 8. And when I do that, I get 8y over 8, which is just y, equals 48 over 8 is 6. So now I've determined that y equals 6. Now I go back over here, and I can use this to solve for x. So here I discover that x is going to equal negative 10 plus 2 times y, but I just determined that y is 6. So this is equal to negative 10 plus 12, which equals 2. So in other words, x equals 2. So that's my solution to these two equations. X is 2, y is 6. Now, to make sure that we didn't make an algebra mistake, it's always good to substitute back these final values into the original equations to make sure that they work. So let's go ahead and do that. So let me start with this first equation here, and I'm going to replace x by 2 and y by 6. So here I go. I have 2 times x, which is 2, minus 4 times y, which is 6. That's supposed to equal negative 20. And if I look at this, on the left-hand side, I get 4 minus 24, which is indeed negative 20. So I get negative 20 equals negative 20. Great, that works. Now let me check that this equation here is also satisfied. I'm going to take this equation and replace x by 2 and replace y by 6 to make sure that it is being satisfied. So here we go. 3 times x, but x is 2, plus 2 times y, but y is 6. That's supposed to equal 18. And if I look at the left-hand side, I get 3 times 2 is 6 plus 12. That gives me 18. And the right-hand side is 18. So that works. Hence, I know that I've solved my system correctly. Next, we'll consider a system of 3 equations with 3 unknowns, namely x, y, and z, and we'll see how to solve for those unknowns. The process that we're going to use is very similar to what we just did for the system of 2 equations and 2 unknowns. So, here's how we begin. Pick any one of these equations. It doesn't matter which one. I'm just going to choose this one. And we are going to pick an unknown and solve that equation for the unknown in terms of the other 2. So we can solve for x or y or z. It doesn't matter. I'm going to solve for y because that looks easiest to me. So I'll take that equation and I'll solve it for y. And when I do that, I will get y equals negative 2x minus 3z minus 4. Once you've done that, the next step is to take the variable that you just solved for. We just solved for y in terms of x and z, and we're going to substitute in for y in all the remaining equations. So I'm going to substitute this expression for y into this equation and into this equation. So let me go ahead and do that. I'll start with this equation. So I'm just going to plug in for y right there. So here we go. This second equation becomes x minus 2 times y, but y we just found is negative 2x minus 3z minus 4 minus 2z equals 5. So that's what our second equation becomes when we substitute in for y. Now let's just simplify this a little bit. So let me expand this out. I can write this equation as x plus 4x plus 6z plus 8 minus 2z equals 5. And now let me combine a few things here. X plus 4x is 5x. 6z minus 2z is 4z, so that's plus 4z. And then I have an 8 on one side and 5 on the other, so I can write that as equals negative 3. So that's what I got when I take this expression for y that I just found and substituted it into equation 2. Now let me substitute this also into equation 3. And let's see what we get there. We end up with negative 4x plus 3y, but y we found is negative 2x minus 3z minus 4 minus 2z equals 0. And now let's go ahead and expand this out and simplify. So we get negative 4x minus 6x minus 9z minus 12 minus 2z equals 0. And now combining some terms, I get negative 10x minus 11z, and that's going to equal 12. So let me recap. I grabbed one of the equations, solved it for one of the variables in terms of the other two. Then I substituted that expression into each of the remaining equations, here and into here. And when I did that, I ended up with this equation and with this equation. And notice that I now have two equations and two unknowns. These two equations just involve the x and the z variables, and they no longer involve y. So now I'm down to two equations, two unknowns. And now I can go ahead and solve these two boxed equations. The procedure is the same. I'm going to grab one of these boxed equations, doesn't matter which one, and solve for one of the unknowns. It doesn't matter which one. So I'm going to start with this equation, and I'm going to solve for x in terms of z. And if I go ahead and do that, I'll get the following. So from here, you can check for yourself that you get x is equal to negative 3 minus 4z over 5. Then what I'm going to do is take this expression for x and plug it into all the remaining equations, namely just this one. And when I do that, when I substitute this into here, I get the following. Negative 10 times x, which is negative 3 minus 4z over 5, minus 11z equals 12. Now I'm going to simplify this expression, but I'm running out of room, so let me give myself a little bit more room here. Okay, so looking at this equation here, and I want to simplify it a little bit. So let me expand out the left-hand side. The left-hand side is going to give me 6 plus 8z minus 11z and the right-hand side is 12. So I can write this as 6 minus 3z equals 12. Negative 3z equals 6. Z equals negative 2. So I just determined that z is negative 2. Now that I know that, then I'm going to go back and I'm going to look at this expression because I had x in terms of z, but I just determined that z is negative 2. So therefore, if I replace z by negative 2 in this expression, I'll find that x is equal to negative 3 minus 4 times negative 2 over 5, which is negative 3 plus 8, which gives me 5, over 5, which is 1. So I just found that x equals 1. So we've just discovered that z equals negative 2 and x equals 1. And now I'm going to go back to this equation here, which tells me what y is in terms of x and z. And I'll substitute my known values in. So this is going to tell me then that y is going to equal negative 2 times x, which is 1, minus 3 times z, which is negative 2, minus 4. And if I expand this out, I'm going to get negative 2 plus 6 minus 4, which gives me 0. So in other words, y is equal to 0. And there we have it. X is 1, z is negative 2, y equals 0. Those are the solutions to these three equations. By the way, as you've undoubtedly noticed, solving many equations with many unknowns can rapidly get rather tedious. But there's plenty of free software out there that allows you to solve the equations in an automated fashion. Let me illustrate. Here I go to a website called Wolfram Alpha. Just type that in, and this is free software, and we'll go ahead and we can simply type in the equations that we want. So I'm going to type in the three equations that we just looked at in our last example. So I want to tell Wolfram Alpha to solve 2x plus y plus 3z equals negative 4. That was the first equation. The next equation is x minus 2y minus 2z equals 5. And our third equation was negative 4x plus 3y minus 2z equals 0. And I ask Wolfram Alpha to solve that for me, and here we go. We see that it puts out the solutions here. It finds that x equals 1, y equals 0, and z equals negative 2, just like we found before.